In this video, we're going to be dividing rational expressions. And to do that, let's first review how to divide fractions. So if I had a fraction being divided by another fraction, the way we do that is we multiply by the reciprocal. So copy the first fraction, multiply, flip the numerator and denominator of the second fraction. And then it's a multiplication problem. So you divide out any common factors if you can, and then multiply the result. We're going to do the exact same thing with these rational expressions. So we have to still factor everything, but before we divide out, we have to set it to multiplication. So copy the first rational expression, multiply the reciprocal of the second one. So looking at this first, I want to make sure everything is in fraction form. This first rational expression is being divided by a polynomial, but I can make this a rational expression by putting it over 1. And then I would copy the first rational expression, and then multiply by the reciprocal of the second one. And then I'm going to go ahead and factor everything. Since this is now a multiplication problem, I factor every numerator and denominator and see what divides out. In this first one, in the numerator, I see a difference of squares. So that's, again, just something you have to recognize. It's going to factor into conjugates. The way I make 4x squared is by multiplying 2x by 2x. The way I get 9 is multiplying 3 by 3. And then one has to be positive and one has to be negative to truly be conjugates. In this next one, I see that this is a perfect square, and the last term is a perfect square. And if I take what those squares are, so 2x times 3, that would give me 6x, and then if I double it, I would get 12x. So this is a perfect square trinomial. And if I know how to factor that using the shortcut, I know it would factor into 2x and a 2x, all positives here, and a 3 and a 3. So perfect square binomial. The 2x times 2x would give me the 4x squared. 3 times 3 would be 9. And then I would have 6x plus 6x would give me the 12x in the middle. On the next rational expression, 1 is as far as I can factor that. In the denominator, I can take out a GCF of 3. That would leave me with 2x minus 3. I look for any common factors. I see 2x plus 3, 2x plus 3, 2x minus 3 divided by 2x minus 3. That looks like all I can do. I multiply everything that's left. So in the numerator, there's only a 1. In the denominator, I have a 3 and 2x plus 3, which I could leave it like that, or distribute the 3 through and get 6x plus 9. Either way. Go ahead and try the 2 on the right, and this last one down here with multiplication and division. Go ahead and see how you do with that. Alright, we're still dividing here. So I'm going to copy my first one, which actually, let me zoom in again. Copy my first rational expression. Oops, that's a y. Some students like to factor as they go. I just caution that you make sure you actually take the reciprocal of the second one. So copy, dot, flip, multiply by the reciprocal. And then start to factor. So this first numerator has a GCF of 2. Divide that out, we're left with x minus y. The second one, this is a perfect square, but that is not. So this is not a perfect square trinomial. But I want things that will multiply to 21 and add to 10. So multiply to positive 21, add to 10. I'm thinking 7 and 3. So I can go ahead and put this into my two factors because the front coefficient was 1. But just be careful, I've got x squared and a y squared here. So I need x times x to give me the x squared and a y times y to give me the y squared. And then the factors that we found of positive 7 and positive 3. So now that's this factored as far as we can get it to go. Over here on the right, I think we should take out a GCF of x first. I'm going to go ahead and write it next to it just for the sake of room. Take out an x. We'd be left with x squared minus 9y squared. So again, once we take the GCF, we look at what's left. This is a difference of squares, so I can keep factoring. So I have my GCF of x, and then I'm going to factor that difference of squares. X times x would give me x squared, and 3y times 3y would give me 9y squared. Then I need my plus and my minus to complete the conjugate. In the denominator here, there's also a GCF of x. And when we take that out, we'd be left with x minus y. Now we look for any common factors that we can see. X divided by x would be 1. And x plus 3y divides out. X minus y divides out. And that looks like all we can do. So the final answer here would be 2 times x minus 3y in the numerator over x plus 7y in the denominator. And again, you could distribute that through if you wanted to. Alright, down here. Now there's no pluses and minuses here. This is actually all factored already. So we just have to multiply by the reciprocal. 3x to the 5th, y to the 5th, divided by 10x squared times 2y squared divided by 5x squared y squared. Right? Multiply by the reciprocal. Copy the first one times flip the second one. Now this is all multiplication. Everything here is already factored, and all we have to do is look for common factors. For example, 2, if I divide by 2, I get a 5. I could divide out, 2 y's, so y squared divided by y squared, and then I have 4 x's in the denominator, so divide out 4 of those with the 5, I'd still have 1 left over. And that looks like it's as far as we can go. So in the numerator, we would have a 3, 1x, right? We had 5 in the numerator, 4 divided out in the denominator. So that still left 1 in the numerator. And y to the 5th, all over, 5 times 5 is 25. That's as far as you can go. Alright, one more. We've got a lot going on here, but it's the same idea. In this first fraction, I have x plus 3, that whole quantity squared. So I'm going to go ahead and rewrite it as x plus 3 times x plus 3. Right? That's what it means to be squared. In the denominator, I have a difference of squares. That's going to factor into conjugates. X times x would give me x squared. 3 times 3 would give me the 9. and plus and a minus to complete our conjugates, times our next rational expression. In the numerator, I can take out a GCF of 2. I would be left with x minus 3. In the denominator, that's already factored. This is 5 times x. And then I'm going to multiply by the reciprocal, right? This is division. So I copy the first one, I multiply by the reciprocal of the second one. This stays the same, multiply by the reciprocal. So now this is all going to become multiplication. So I take the reciprocal, and let's go ahead and factor this one. I want factors that are going to multiply to 12, add to 7. So I'm thinking 3 and 4. So when I factor that denominator, I will have x plus 3 and x plus 4, because 3 times 4 multiplies to 12, 3 plus 4 adds to 7. The front coefficient was 1. I can go right into my factoring. Now this is all multiplication. It's okay that there's 3 rational expressions here because it's all multiplication. I look for things that divide out. X plus 3 divides out, and x minus 3 divides out. Another x plus 3 divides out. One of the x's divides out, and that looks like all we can do. In the numerator, the only thing I have left is a 2. In the denominator, I have a 5 and x plus 4. So you could leave it like that or distribute the 5. And there you go. So with any multiplication or division of rational expressions, if it's division, we copy dot flip, multiply by the reciprocal, and then when it gets to multiplication, factor, 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 divide out common factors. Multiply whatever's left.